Today's lesson is on perfect cubes, and we're going to factor by what we call SOAP and grouping. Okay, first of all, what do cubes look like? We're going to take a look at what cubes look like for the numbers 1 to 10. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27. What is 4 cubed? 4 cubed is 64. 5 cubed is 125. 6 cubed is 216. 7 cubed is 343. Do you know what 8 cubed is? 8 cubed is 512. 9 cubed is 729, and 10 cubed is 1,000. So you should be familiar with these numbers. It will make it a lot easier to be able to do the cubic factoring. All right, so we have two ways of doing cubic factoring. The perfect sum means that two cubes are being added, while the difference of cubes means that two cubes are being subtracted. So what does SOAP stand for? SOAP stands for same sign. So whatever the sign is between your two cubes, you're going to use it in the first set of parentheses. Opposite sign comes in the trinomial, that will be the first sign, will be the opposite of what is in with the binomials. And then your last sign is always positive. In the difference of cubes, again, the same sign is going to happen both in the cube as well as in the binomial of the cubes. Then your opposite sign is going to happen in the trinomial, and the last one is always positive. We're going to do some examples. Okay, let's take a look at example 1. We're going to factor x cubed plus 125. Notice this is a sum of cubes. Our cube of x cubed is just x, and the cube root of 125 is 5. We're going to place these into the binomial. So whatever your cube roots are, they go into the binomial. And you use the same sign as what you started the problem as. Okay, you're going to square the first term and place it into the second set. You then multiply the terms that are in the binomial, and they become the second term. Then you square the second term in the binomial, and it becomes the last term in the trinomial. Then we use our SOAP acronym. Notice that this is the same, this is opposite, and the last sign is always positive. Let's take a look at example 2, 8x cubed minus 27. Please identify what the cube roots are of 8x cubed and 27. That's right, they are 2x to the cube minus 3 to the cube. Again, you place these terms into the binomial, and you keep the same sign as the problem. Next, you're going to square the first term of the binomial and place it into the second set as the first term. Then you're going to multiply your binomial terms together, and they become the second term in the second set. Last, you square the second term of the first set, and you place it into the second set as the third term. Then last, we use our acronym SOAP, same, opposite, always positive. Okay, what about this example? Where are the cubic terms? As usual, sometimes when you are factoring, you need to look for the GCF. In this case, the GCF is 2, and we must factor out the 2. Now we can see the cubes. What are our cubes? That's right, our cubes are x and 4y. So we're going to place the cubes of the term into the first set. And again, it is the same sign as what is in the problem. We're going to square the first term in the first set and place it into the second set. We're going to multiply the terms from the first set together and place them into the second set. So you have x times 4y, which gives you 4xy. And then last, we take the 4y, square it, and it goes into the second set as the third term. Then last, we use the acronym SOAP. That was the same. This is the opposite, and the last sign is always positive. All right, what is going on here? This is a little tricky because x to the 6 minus y to the 6, notice we have a difference of squares and a difference of cubes. So we can write this as x cubed squared minus y cubed squared, or we can write this as x squared cubed minus y squared cubed. Notice that due to the exponential rule of powers that we can multiply either one of these out and you will still get x to the 6 minus y to the 6. In general, factor the difference of squares first before the difference of cubes. So we are going to go with the first example. Okay, so here's the difference of squares, and we're going to factor that out. And so we get y cubed plus y cubed, and then x cubed minus y cubed. So we have a sum of cubes and a difference of cubes. Let's take a look at the sum of the cubes. Okay, so we have an x cubed and a y cubed, which means that our binomial is an x plus y. So remember, we're going to keep the same sign of a plus of the addition with the x plus y. Okay, square the first term and place it into the second set. Multiply the x and the y together, and it becomes the second term of the second set. Square the second term in the first set and place it in the second set as the third term. And again, use our acronym SOAP to place your signs. Same, opposite, always positive. All right, let's take a look at our difference of cubes that we have. Okay, so again, it's x cubed minus y cubed this time. Notice that our sign, because it's a difference of cubes, is negative, but it's still the same sign that goes into the binomial. Okay, square the first term in the first set and place it into the second set. Multiply the terms of the first set and place it together and place them in the second set as the second term. Square the second term in the first set and place it in the second set as the third term. Use the acronym SOAP to place your signs into the second set. SOAP stands for same, opposite sign, always positive. Success. Now we're going to put these together. Okay? And that is what the simple x to the 6 minus y to the 6 turns into when you factor it out. Now we're going to do factoring by grouping for polynomials with 4 or more terms. Okay, we're going to group the first set of terms and the last set of terms with parentheses. We're going to factor out any GCS from each group so that both sets of parentheses contain the same factors. Then we factor out the GCF again. Okay, let's do this example. First we group. Notice we just placed parentheses around the first two terms, and then we placed parentheses around the third and the fourth term. What is going to be the GCF for b cubed minus 3b squared? That's right. It is going to be a b squared. Notice that the GCF for 4b minus 12 is 4. Please notice that in the parentheses we have the same factor, b minus 3. Okay? So in step 3, we're going to factor out the GCF again. What we're really factoring out is that b minus 3. And then we put the b squared and the 4 together into the second binomial. And that is group factoring. Okay? Let's do example 2. Notice that we have 2x cubed minus 16x squared minus 8x plus 64. These are all even numbers. Do we have a GCF? And if so, what is it? That's right, we have a GCF of 2. Now we have x cubed minus 8x squared minus 4x plus 32. We're going to put parentheses around the first two terms and parentheses around the third and fourth term. What can we take out of the negative 4x plus 32? That's right, we're going to take out the negative 4. But notice that when you do, that this is going to go from a positive to a negative because you're extracting a negative 4 out. Notice we were able to take out an x squared out of the first two terms, and thus we have the same factor x minus 8 from both of those. Okay, so now we move the x minus 8 out, and we have parentheses there, but notice that we have an x squared minus 4 together. And remember, this is what we call a difference of squares. Okay, so that means we can factor that again. Okay, and we reviewed the differences of squares earlier. So the square root of x squared is x, and the square root of 4 is 2. So this breaks down into x minus 2 and x plus 2. But now that is all factored. That is all I have for you. The end.